In our practice exercise 14.13 called expunge, we want to write a method for it. It's going to accept a stack of integers as its parameter. It's going to make sure the stack's elements are in non-decreasing order from the top to the bottom. And to do this, we're going to remove any stack element that is smaller than any of the elements on top of it. So we're given an example like this, and it needs to appear like this. So the way I'm looking at this is, remember, this is the top and this is the bottom, right? We want these values right here, we want them to continuously be greater. So 5 is greater than 0, 10 is greater than 5. Since 3 is not greater than 10, we're going to want to remove it, as shown here. Now we're going to compare 7 to 12. 12 is greater, so we remove 7. Compare 5 to 12. 5 is smaller, remove 5. 8 to 12, 8 is smaller, so remove it, so on and so forth. Now, it's telling us we can use these two methods. I'm not exactly sure what they do, so I'm just going to code it completely myself. It is not that bad. We're allowed to use either a stack or a queue as an auxiliary storage. We can't use both. For this, it doesn't really matter which you use. I just chose a stack. And so this is the header, and this is our auxiliary storage. We have our stack being passed in as S, and then our new stack as S new. Now, we know we want to examine all of these. So I'm going to make an exterior while loop, and we're going to run this while our s dot is not empty. And so inside of here, what we're going to want to do is basically get this value and compare it to the next value. And if it's smaller, well, we'll deal with that in a second. Let's first code this. We're going to have int temp that's going to hold our current value. We'll set it equal to s dot pop, so we can continue to look at this. And this is where we're going to handle our exception. We're going to say while, and we want to run this first as long as our s dot is not empty. That's why I have the not in front. And the reason, if we're going to be inside of here, this is us removing a lower value. So while it's not empty, that's just for a back case like this, because we can't really compare this to anything, right? So we want to hop out of this loop before we hit this next part, which is we want to compare our current temp value, which is this value, to this next value, which is going to be s dot peak. We just want to peak, not pop it off. Now, what is the comparison here? Well, we want this value right here, our temp, to be less than this value. If this value, our temp value, is greater than this, we're going to pop this off. So if temp is greater than this, we're just going to do s dot pop. Otherwise, when we either skip or come out of this while loop, we're going to want to add into our new stack. So we're just going to do s new dot, and we'll do push. And that's going to push this value to the new stack, and that's just going to be the temp value. And that's going to conclude our while loop. From here, all we're going to want to do is add back into our original stack. So while s new is not empty, we're going to do s dot push, where we have our s new dot pop. And you'd be mistaken if you think this is all you have to do, because when we're dealing with sets, remember, it is first in, last out. So what that means is we're going to have this backwards. So we need to reorganize it by pushing it back to our new stack. That's going to have it be in the correct order. You're going to have a pop here, and then all you need to do is just recopy this and paste it back in. That's pretty much going to expunge this original and have it be how we want it to be. This is the code for it. That's how we would solve for it, and that is my thought process for it. Okay, we don't need two of those for sure. These are all the tests. This is the code, thought process, and the exercise 14.13.